Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Cobblestones by Sotir. And here are the rules. We have deconstruction Sudoku rules, where we need to place 9 non-overlapping 3x3 boxes into the grid and fill each box with the digits 1 through 9 such that digits do not repeat in rows, columns, or boxes. And cells outside the boxes are empty but have a value of 0. So basically we can construct multiple boxes here, and they have to contain the digits 1 through 9 in them once each. Yeah, so this could be an example of how you construct these boxes. And the thing is, every digit that's outside a box, or every cell that's outside a box, does not have, are empty. They do not have any digits in them, but they have a value of 0. And obviously the digits would have the value equal to those digits. We have odd and even, where gray circles have odd values, and gray squares have even values. Additionally, each square or circle counts the surrounding up to 9 cells, including itself, for either the total number of empty cells or the total number of digits. So that means in this example, this works because this could count the number of, well, actually all of them work, I guess. Well, that doesn't really work. But anyways, this could work if this digit were a 7 here in this scenario, because the number of total number of digits would be 1, 2, 3, 4, 5, 6, 7 in the 3x3 area that's surrounded there. If this were a square, it could be 2, right? Then that would be the number of empty cells in this cell here. So this would actually have to be 1 for the total number of empty cells around in the 3x3 area surrounding or centered on that circle. And it says, note, 0 is an even number. So right. Gray circles have even value, odd values. Gray squares have even values. So you could have 0 in a square as long as none of the cells surrounding it would be empty. So that's the odd and even values. Remember, 0 is an even value, so keep that in mind. X sums, we have a clue outside the grid, indicates the sum of the first X cells seen from the clue in that row or column, including empty cells. Including empty cells. So clue outside the grid indicates the sum of the first X cells seen from the clue in that row or column, including empty cells, where X is the first digit seen from that clue. So, for example, if you could have something like a 7 here, and then the first 7 cells must add up to 19 here, if that were the case. So you could have 7 with 4 and 8 here or something, right? And this could be the first sum of the first 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. But obviously we could have no digits actually there, so that would essentially be the sum of the first 8 cells, but it would basically be the sum of the first 3 digits, essentially, if that were the case. So that's an example of how these x sums work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, all the circles then have to contain valid digits in them. So this must be part of some 3x3 box here. And it would also be part of the 3x3 box with this cell. Let's draw, well, we don't know actually. We don't know if that's, so we know this is a boundary and this is a boundary. Because these three have to be in the same region. The problem with the, okay, so these are odd. How does that work? Oh, okay. I understand how that works. So, this, if we have, say this is a box, well, actually, let's go here. Say this was the box. There's no 3x3 box that can occur here. But the problem is this has to count the number of empty cells or the total number of digits in the 3x3 area centered on that cell. Well, the problem with that in this scenario is you can't have a 3x3 box here. So this is guaranteed to be 4 for the count of digits surrounding it in the 3x3 area surrounding it, and 2 for the empty cells. But that's none of those are odd digits. Therefore, this doesn't work. We also know this doesn't work for the same reasoning. We have 0 empty cells surrounding it and 6 digits surrounding it. So that's not going to work. Therefore, this scenario has to be something like this. And then this has to be part of the region there. So this must be a region here. This will then count the total number of digits, which is 5, or it's 1 for the number of empty cells here. So this has to be a scenario here. It's the same thing for this area here, right? We have the same initial situation here because this has to be an odd sum here. So then we have to have this be, that be a region, and then this be a region. Okay, so we'll remove colors here. We know, so this has to be 1 or 5. This must be 1 or 5. This has, we could have another region there. So this has to be a 4, because that's surrounding this region here. And this must be 4. It can't be 0 because 0 is not a digit. We know there's a border starting from there and there. So either it's all of these, it could be something, it cannot be this. Okay, so what are the regions that are possible, the 3x3 boxes that are possible from, that must include this circle? This is possible. This is not, because if this is the region, this would count 1 cell that's a digit or 3 cells that are empty, which none of which are possible. So this is not possible. This is possible to be a region. This is possible. This is possible. I think all of these are possible to be regions. No, this is not possible Because if this were a region, here, well, no, you could have something here. Okay, so those are all possible. Similarly here, we cannot have one here. So this is the first 4 cells here. Add up to 7. So this must be 4, 2, and 1 there. Whoops, 1. This can't be 1, so it has to count. It can't count the number of empty cells. So this must be 7 or 9 here. And we could potentially have a cell there. Here can be, again, the number of these could be potentially regions. Can we actually have one here? I guess so, right? Because then we could have one here. This is going to have to be a valid number because it can't be 0. This could be 0 here. The first 4 digits here add up to 15. Or first 4 cells, which are these 3 digits. So cannot be 1 here. This has to be 5. Counting the number of digits surrounding it. 4, 5, and 8 add up to 17. Okay. Six, 7, 8, 9. Remaining digits in this box. We have 3 through 9, or 3, 5 through 9 here. Once these 2 digits are guaranteed not to be in the sum here. Four, 5, 6, 7, 8, and 9. If one of these is a 9, that could work because then you could have 3, 4. No, that doesn't work. No, that does work. 3, 4, 9 could be here, so they were missing 16. So the rest of the cells in this row would be counted to add up to 29. So that is possible. So we could have 9 there. This has to be 7, 1, or 9 here. Remaining digits in this box have to be 1, 2, 3, 6, 7, and 9. Interesting. So this digit, okay, this digit is 2, 4, 6, or 8. This digit also has to be 2, 4, 6, or 8. Oh. This cannot then be centered with a box around here, right? Because this is guaranteed to not be 0. It can't be 0 because if it's 0, this could not be a digit. Same with this. So what we cannot have then is a box centered or with a upper left-hand corner there. Because if we did, this would have to be 9 or 0, and it can't be either. So this is not valid. for this circle. Same with this, then. It cannot... actually, we don't have anything there. This, I guess we're looking at the lower right-hand box. So this can't be the lower right-hand box, because then this would not be valid. Hmm. Okay. To add up to 29, we have to have at least 4 digits here adding up to the 29, because 3 digits uniquely can only add up to 24 at most. So, these boxes then, you cannot have this be above row 9. Because if it were above row 9, then you would not be able to add... Well, you could have 9 with 5, 7, and 8 here. That is potentially possible. So we could actually have that. Interesting. So if we had one there, can this ever be a number? It has to be if it's this way. It cannot be if it's in the center of a 3x3 box. So this is only a number if it's something like this, or it's something like this. Huh. In which case this would be 6. So this is either 0 or 6 here. That's interesting. If it's 0, obviously none of these are in a box. What else do we have? If we do have something like this, though, or something like this. So say we have something like that. This has to be part of a box. It can't be from there. So then I think it has to be here necessarily. Right, because it must include this and this. Let's try it this way. Maybe that will clear things up. So we have that. These two are part of the same box because it cannot be separate boxes because this can't be a 3x3 by itself. So it can't be these. Can't be here with that as the lower right, so it would have to be this way. So I think you would have to have something like this or something like this. And then this would have to be a 9 with 5, 7, and 8 there. So that's potentially possible. Hmm. Otherwise, if you have 0 here, then this could be part of a separate region. That's interesting. Hmm. Hmm. Oh, that's not gonna work, is it? We need, yeah, if this is empty, we need to fill in 5 more 3x3 boxes. But that's no longer possible. Huh. Um, right, because we can't, like, this is the farthest one could go here, and the farthest one could go here, but we don't have space for a third here. It's the same with this area. So this cannot be 0. Therefore, this has to be 6. And we know these 3 are all in the same region. But we don't know which. It can go either up here or down here. Hmm. Hmm. Oh, this is where it's differentiated between that and that. That's the only non-symmetrical part of this puzzle. Interesting. Hmm. Well, obviously, what you cannot have is something like this and then this. Because then this would not be able to be even. Also, we have the sums, which are not symmetrical also, so that does change that. Okay. Oh, what happens if we do have this? So say we have pink, these are part. So I guess these would be the same region. This would be 0 and 0. That would be valid. Hmm. $19 can be the sum of 3 digits, so that's fine. Um... What happens if we have something here? So say we had this was a box. Then we'd have to have that as a box. Can this actually ever be 2 is kind of the question, right? Hmm. Hmm. So then that would force this to go that way. That's interesting. So can we actually ever have this? The answer is no. Because then this is not part of a 3x3 box. Because it's blocked here. So this is invalid. Can this be valid? Same problem, right? It's blocked here, so this is not valid either. So it's going to be the same with these two, I think, also, right? If we try to have something there, this is blocked from having a 3x3 region. How about this? That's fine, because this can always go that way, right? So these are fine. These are fine. Okay. This is obviously... Huh. So these have to be the digits 1 through 9 here. This cannot be 5. That's 1, 3, 7, or 9. Can it actually be 1 is kind of a question, too. Hmm. Oh. This cannot be the bottom right. If this is the bottom right, this would necessarily have to be 4. So that doesn't work. Oh. So none of these can be in the bottom. Right. So all of these, including this cell, cannot contain this cell. So this cell here must have a bottom of one of these. So this has to be then, as I said, 5, 7, 8, and 9. So this has to be 5, 7, 8, and this cannot be 5, 7, 8, or 9. It's 3 or 6 there, because it's not included in the sum, guaranteed. The 9 has to be one of these digits here. So 9 can be here as the first, than the other two. So 9 has to be one of these 3. Therefore, this must be empty. This must be empty. So we cannot have something going like that. So since these are both empty, 9 has to be one of these two. So we know these are definitely part of a box. And we cannot have this as a scenario. So these two must be part of this region. So then this is a region here. So this sees 6 cells that are digits and 3 cells that are not. So this must be 3 here. There's no 3 here. This could still go either way. So this could be 3 this way. So this is 5, 7, 8 here. And this has to be, this could be 9 also. To add up to 29 here. This could still go this way. Okay, so this could work. This adds up to 21, and it cannot be 3, so this is at least 4. Can it be 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be the sum of 5 digits. So it's possible. So this... Again, cannot be pink this way and yellow that way, because then this would not be a valid sum. What happens if we do that? Then this would be 8. That is possible. What happens if we do this? Okay, so this would then have to be 6 or 2, depending on where the yellow is. So say this was all yellow. This would be 2, and that would be 6. How did we... I'm trying to remember why... So these make sense, right? These two make sense, and these two make sense. How did I eliminate that as a possibility? Because this is at most 8. You have to have a cell going, a 3x3 box here containing this digit here, but it can never get down to here. So that would be the sum of 3 digits. That's why that's working that way. Okay. Okay, so what happens in this scenario? Hmm. Could this be... Okay, let's go through these scenarios. So it's either here or it's here. We're not sure which is the valid box, central box. What happens if it's the other way? Then... Oh, that's interesting. Could not be 9 here, then. This can't be the case. So if we try to have this, we either have a box here or a box here. If this is a box, this is surrounded by 9 digits and 0 empty cells. If we don't have the box here, we have the box here. This is surrounded by 9 digits and 0 empty cells. So that's not going to work. Therefore, we know this has to go this way. So then this goes this way, which means this... these two must be included in the same region. So obviously can't be here, can't be any of these anymore. Why was this eliminated? How did I eliminate this? Huh. Oh, because this doesn't work, right? That would be an empty cell trying to... Right. Empty cell trying to have 1 or 3 here. So then we do know then this has to be the box here. We have to have a box here. So then this would be 8. Because and this cannot be part of the region. So then the region has to go here. So we know this is a region here because we can't have all 9 of these connected. This would be Z empty, empty. Has to have at least 3 digits here to add up to 19. So that would be 5, 6, 7, 8. So this would be 8 or 9 here. So it could be 4 digits here, adding up to 19. This is at least 4 digits, so this must be at least 5 here. Obviously no 8. 8 eliminates 8 as a possibility here. This is not first 5 digits, so it has to be 2. It can't be 2. It's 3 or 4. Can't be 4. So this is the first 3 digits here, adding up to 16. So that means 16 minus 3 is 13. So we have 4, 9, 5, 8, or 6, 7. No 8 here, so no 5 there. And those are all fine. That means 3 cannot be here. So to add up to 19... 8. So if this were 8, that would be 8, 3, and 8 to add up to 19, which doesn't work. So this is 9 here. So this cannot be 4, 9 here to add up to... Therefore, this is the sum of these 4 digits. So no 9 here. This is 12, so these two must add up to 7. 19 minus 12 is 7. So that means we have 1, 6 here or 5 here. So this is either 1, 6, which adds up to... So 9 eliminates 9 here. So therefore the 9 has to be here to add up to these. Therefore we know this is the region here. Okay. So this is 9 here. The first 9 cells add up to 29 here. 5, 7, 8, and 9. This is 3 surrounding there. This is obviously 0. That's 0, 0, 0. This is 3 cells, empty cells here, so this has to be 3. This has 9 digits in it, so it must be 9. That means we cannot have 9 here. This has 1, 2, 3, 4, 5, 6, 7 digits and 2 empty cells, so that's 7. So this cannot be 7 remaining in this box. This has 1, 2, 3, 4, 5, 6 digits and 3 empty cells, so this is 6. This has 1, 2, 3, 4, 5, 6, 7 digits and 2 empty cells, so this is 2. So there's no 6 here because there's no repeats in the row. It cannot be first 4 digits or 5 digits or 7 digits. Right? 7 cells, I should say. Because that's only 3 digits and one of them is a 2, which does not add up to 21. So this has to be 8 or 9 here. Okay. If it's 8 here, what would that mean? These digits would add up to 21, these cells, and that would be 2, 6. Okay, so let's mark everything that's not in a box as gray so that we don't get confused. So if we have 8 here, that's 8 here, 16, that would be 5 in that instance. if that were the case. If we have 9 here, that would be 8 plus 9 is 8 plus 9 is 17. So the two digits here would have to be 1 and 3 to add up to 4, to add up 21 minus 17. But 3 cannot be in either of these spots, so that doesn't work. So this must then be 8. This is 5. So the first 8 cells, we have 8 plus 2 plus 5 plus 6. 2 and 8 is 10. 5 and 6 is 11. That does add up to 21. This is 5, 7, or 8. Huh. So we're guaranteed a 7 has to be one of these two digits. We have 3 digits here adding up to 16. 9 here, we already did that. 17's done. So this is done. So this is 4 cells that are digits. This is 5 cells that are digits. This is 9 cells that are digits. So this is done, this is done, this is done. We've also satisfied the column, so that's done. 4, 8, and 5 add first 4 cells. 4, 8, and 5 add up to 17. 3 is somewhat done. This has 3 empty cells, so that's done. 8 digits, that's done. 6 digits, so that's done. 7 digits here, so that's done. 2 empty cells here, done. 6 digits, that's done. 3 digits here, so that's done. And these are 0 and 0, so those are done. 19, this is essentially done, going that way. 29, this 21 is done. 7 is done this way. Also 4 here, this has 1 empty space, so that's done. 9, first 9 cells add up to 29, so that's done. 19, we are not quite done yet. Can we have an 8 here? That would mean first 8 digits add up to 19. So that would be 1, 2, 3, and 5. So that could work. Can this be 5? That means 7 would have to be here. This would have to be 6 and 8 as a pair, which does work. So if this is 5, this would have to be 6 and 8. Oops. 6 and 8 here. If this is 7, 1, 2, 3, 4, 5, 6, 7. Oh, it can't be 8. So if this were 8, that would be 6 cells trying to add up to 19. 6 digits, I should say, adding up to 19, which is impossible. So if it's 7, that means the remaining 4 digits must add up to 12. So it would be 1, 2, 3, 6 or 1, 2, 4, 5 here. Okay, this can't be 1 or 3. This can't be 2. That seems fine. We do know 9 in column, in this box here. Can't be here, can't be here, so 9 has to be one of these 3. So we don't actually have very many restrictions here. We do know that these have to be either 6, 8 as a pair. Um, 2 cannot be any of these digits here. So remaining digits in this lower right-hand box, I guess we'll make it 9, are 1, 4, 6, 7, 9. Obviously, 9 cannot be here because of 9 in the column. 2 here eliminates... So where's 2 in row 9? Cannot be... This can't be 1 or 7. So we have 4, 6, or 9 here. We know we have a 1 or 7 there. Guaranteed. So 7 can't be here, 7 can't be here. 7's one of those 3. We know 2 has to be one of these 3 here because 2 can't be here and 2 can't be here because of 2's in the boxes. 2 eliminates 2 from being here. This can't be 2 because of the sum, so 2 has to be one of those 2. That means 2 cannot be here. Um, hmm. Hmm. 3 eliminates 3 here. So 3 in box 3 has to be one of these 2 digits here. That eliminates 3 from being there, so 3 has to be here, which means 3 can't be... we already knew 3 was there. Interesting, okay. So 3 can't be here. 3 cannot be here. Oh. 3 can't be here because of 3 in the column. 3 can't be here because of 3 in the row. 3 can't be here because of the sum, so 3 has to be one of those 2 digits, which eliminates 3 there. So where's 3 in box 7? It has to be here. That means 3 is there. 3 can't be here in box 4. So 3 has to be one of those 2 digits there. Okay. So we know there's a 6 here. We know there's a 6 here guaranteed. That eliminates 6 as possibilities in the rest of that row, so this cannot be 6. This is 4, 9 as a pair. That eliminates 4 and 9 in the rest of the box. So this is 1, 6, 7 as a triplet. That means this can't be 1, 6, or 7. We have what? 2, 3, 4, 5, 8, and 9 as possibilities. There's no 3 here. This can't be 8 because of 8 in the column. So this cannot be 4, and you can't have 9 here. So, if this tried to be 6 and 8, if this was 5 and 6 and 8, we cannot have a 1 or 3 here, so 1 and 3 would have to be here, and therefore 2 and 4 would have to be here. But that's not possible now because of the 4, 9 pair in the row. So, this has to be then 7, which means this can't be 7. Then this cannot have an 8 in it. If it's... We have to have a 4 in one of these 3 cells. So these cannot be 9, because the first 7 cells, which is 5 digits, must add up. It's 19. It's 19 minus 7 is 12. So these 4 digits must add up to 12. So this is 1 through 5. That guarantees this is a 9. So this cannot be 9 here. This then necessarily includes 8 and 9 here. Can we have 7 digits with that? 17, we could, if it's 7 there, so that's 24, so the next 3 digits would have to add up to 29 minus 24, which is 5, which is not possible, because the minimum you can have for 3 unique digits is 1, 2, and 3, adding up to 6. So this cannot be 7, it's 5 or 6 here. Huh. Huh. Can we have 6 digits? 1, 2, 3, 4, 5. 6, 8, and 9, then. So if this is 5, obviously this is 7. If this is 6, 29 minus 23 is 6. So these two digits would have to add up to 6. So we'd have 1, 5 or 2, 4 here, if that were the case. But this is actually not that restrictive. We just know that, okay, this can't be 7. So since this can't be 7, they cannot have 5, 7, 8, and 9 here. So this must then be 6, which does mean that we have to have 1, 5, 2, or 4 here. 6 eliminates 6 in the rest of the column, so this can't be 6, which means where's 6 in box 7? It must be here. Therefore, 6 cannot be any of these digits. This has to be a 2, 5, 6, 8 quadruplet. This can't be 2 or 6, so we have a 5, 8 pair in row 9, which eliminates 5 and 8 in the rest of the row. So this can't be 5 or 8. It's 2 6s a pair. Interesting. That means we have a 5, 8 pair here. That eliminates 5 and 8 in the rest of the box. Also column, so no 5 here. So this has to be 1, 3, and 4 here. No 3 here because of 3 in the column. Remaining 2 eliminates 2 as a possibility here. So this is 1 or 4, which adds up with 2 and 5 to add up to 6, which is needed for these 6 digits here. So this is essentially done also. This is done. It's done. This is done. Remaining digits in column 6 can be 1, 2, 3, 4, 7. So this can't be 2 because of 2 in the column. This can't be 3 because of 3 in the box. Okay. Where is 8 in box 5? Can't be here anymore because of the sum. X sum can't be here because of the 8 in the row. Can't be here because of the 5, 8 pair in the column. So 8 has to be one of these two. Which means this can't be 5 and 8 to add up to 16. It's 6 and 7 with the 3 adding up to 16. That eliminates 6 and 7 in the rest of the column and box. So this can't be 6, which means this can't be 1 to add up to 7 there. 6, 7 eliminates 6 here, so that's 2, which makes this 6. So to add up to 19, this has to be 1, 2, 3, 6, and 7. So no 4 here. This is 1, 2, and 3. 2 is here. 2 is guaranteed to be one of those two. Okay. Remaining digits in box 2. We have 1. No 2, no 3. You could have 4, 5, 8. 8 can't be here. So where is 8 in this box? 8 has to be here. 3 eliminates 3 here. Where's 3 in box 3? It can only be here now. So that's 3. Remaining digits in column 7. We have 8, 5, and 1 out of 1 or 4. 8 cannot be here because of 8 in the row. Where is 7 in this box 5? It can only be here now. This is 1, 2, 4 as a triplet, which eliminates 1, 2, 4 in the rest of the column. So this can't be 1 or 4. It's 3, which makes that 1, which makes that 4. 1 eliminates 1 here. So this is a 2, 3 pair. 4 eliminates 4 here. So where's 4 in box 5? It has to be here. That means this can't be 4 here. It's 1, 2 as a pair, which means this can't be 1. It's 5. This can't be 1 or 5. It's 4. And 5 and 2 add up to 7, which with the 12 adds up to 19 here. So this cannot be 2 here, no 2 here, no 2 here. 2, 3 as a pair there. This is 1, 5, 8. This must be 2 and 4 to add up to 6. Therefore, there's no 2 here. And the rest is essentially... Okay, 4 eliminates 4 here, so that's 9, which makes that 4. The rest is basically deconstruction Sudoku. So... We have a 1, 6, 7 triplet in column 10, which eliminates 1, 6, 7 in the rest of the column. So that leaves us with 2, 5, and 9 left. And 2 and 9 can't be here because of 2 and 9 in the row. So this is 5. Therefore, this is a 2, 9 pair there. 5 eliminates 5 here, so that's 1. There's no 1 here. That leaves this as 3 and 7. So we have 3 here, because 3 can't be anywhere here, so this is 7. 7 eliminates 7 in the rest of the column. So we have a 1, 6 pair in column 9. That means the remaining digits are 4 and 8. Okay. Where is 7 in box 1? Cannot be here, so it must be one of these 2 digits here. That eliminates 7 in the rest of that row, so no 7 here, it's 6. No 6 or 7 here, it's 1. No 1 here, so it's 2, which makes that 1 there. 1 eliminates 1 here, so it's 6. This can't be 1 or 6, it's 7. That means this can't be 1 or 7. It's 6, which makes this 1, which makes that a 7 there. 6 eliminates 6 here, so it's 7. That leaves this as a 4, 7 pair here. Interesting. So we have a 4, 7 pair here, which leaves the remaining digits in box 1 as 1, 5, and 9. That eliminates 1, 5, and 9 in the rest of the row, so no 5 here, that's 8. No 9 here, that's 2. Makes that 9. 8 eliminates 8 here, so it's 5. 2 eliminates 2 here, so it's 3 and 2. 8 eliminates 8 here, so it's 4 and 8. The remaining digit here is 6, which makes that a 1. Remaining digits in row 6 are 3, 4, and 7. 3 and 7 can't be here, so it's 4. 3 can't be here because of 3 in the column, so that's 3, which makes that 7. That eliminates 4 in the rest of the box. This can't be 3 anymore. Remaining digits in box 4. We have 1, 2, 5, 8, and 9. 7 eliminates 7 here, so that's 4, which makes that 7. This can't be 2 because of 2 in the column. This can't be 2, 5, or 8 because of 2, 5, 8 in the row. So this is 1, 9 as a pair, which eliminates 1 and 9 in the rest of the box. So now this is 2, 5, 8. This 5, 8 pair eliminates 5 and 8 in the rest of the column. So this must not be 5. It's 1 or 9. We have a 1, 5, 8, 9 quadruplet in column 2, which eliminates 1, 5, 8, 9 in the rest of the column. So this can't be 1, 5, 8, or 9. So that's 2, which makes this 5, which makes that 8. That eliminates 8 here, so that's 5, which makes that 8. That eliminates 8 there, so it's 5, which makes that 8. So this has to be 9 there. 9 eliminates 9 here, so it's 1 and 9. That eliminates 1 and 9 here, so it's 5. That means this can't be 9, it's 1. This can't be 1 or 5, it's 9. And that's a solution. Yeah, pretty cool, actually. The deconstruction wasn't too bad. I'm usually not very good at actually deconstruction puzzles. I've done a lot of both deconstruction and construction puzzles. I definitely prefer construction puzzles because it feels a lot more intuitive to me. But with these digits having to be the number of digits, with these squares and circles having to be the number of digits in the 3x3 surrounding area or empty spaces, that did restrict things a lot. So that was pretty reasonable to actually deduce pretty quickly. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.